how do you know when you're done? Like, what is the end of my problem? We all wanted to know. Like, when do I stop? And with simplifying trig identities, it's like when you think you have something that's easier than what you started with, more simplified, right? And that's hard for us to judge and say when that happens. Okay? When we're verifying trig identities today, oops. You know the answer. So instead of being just like a random trig expression, like over here in 35, we had cotangent theta, secant theta. What is that? I don't know. Let me see what I can get. Today, it will say cotangent theta, secant theta equals cosecant theta. So all along, you'll know what you're trying to get to. Won't that be nice? You'll feel like, okay, I can work on this and try to think backwards, and I know I'm trying to get to a cosecant theta. So if I'm getting close to something like a 1 over sine theta, I know I'm on the right track. So it's kind of calming. We understand where we're going. Here are some helpful tips for today. So this one is new, the first bullet point, because you'll actually have two sides to your problem. You'll have a left and a right. And the rule is work with one side at a time. Okay. Now, in most cases, I just do like one side all the way through. So I'll like work on the left side and make it look like the right side, or vice versa. Okay. You technically can change both sides. You can change the left and you can change the right, but I want you to listen very carefully to what I'm saying right now. You can't move things across the equal sign. So you can't say, let me add a cotangent to both sides. That's not allowed. If you have cotangent on the left, you could change that to cosine over sine and simplify with what you've got. But you can't move it to the other side. Okay, so we're not solving an equation where we move things around. We're just changing one side or changing another. We can swap which sides we want to change, but we don't change them at the same time. I usually recommend starting with the more complicated side. Obviously, that one's going to simplify. So it's going to be like the problems that you see on the board. Okay, here is the new tip that I didn't give you yesterday. And I'll do my first example where I show how you can use multiplying the denominator by its conjugate to verify or simplify a trig identity. It's just one of those tools that mathematicians have in their pocket. Oh yeah, that conjugate thing, that can be super helpful. It can get me something, what it actually does is it gets me something maybe that looks like a Pythagorean identity. So that's just another one to add to your tool belt. And then I know that I tried to talk to each group. You know, I went to different groups, and some groups said, we don't feel confident in anything. We don't know how to do anything. Okay. The recommendation is still the same. Don't show up tomorrow not having done anything. You got to try something. Even a dead end is going to be helpful. Even 2 steps in, you're going to learn something from the second to the third step, or why you shouldn't have done the first thing in the first place, versus you writing down the problem and leaving it blank. You have nothing to learn. And it looks really hard when you see other people do it. So you got to do something. Okay. And then lastly, don't forget the same tips from yesterday still apply to verifying trig identities as it does to simplifying. So converting all to the same trig, converting all to sines and cosines, doing some factoring, and make sure before you leave today that you've taken the time to either get 21 down in your homework or in your notes, because that's a tough one for a lot of people to see that factoring there. So I'm glad we talked about that. And then, of course, combining fractions by multiplying or adding. So we'll do one together, and I'm going to demonstrate this new tip, multiply by the conjugate. So here's what a new problem will look like. Isn't this beautiful? We have a left and a right. We know what the answer is. So we have sine squared t over 1 plus cosine t equals 1 minus cosine t. And if you don't like the letters that the book chooses, if you change it to thetas or x's, that does not bother me. Okay, so, like if I was looking at this problem as a verifying identity on my homework, I'd be like, which side looks more complicated? Probably the left. There's got more stuff going on, right? And it's a fraction. Ugh. Okay, so I'm thinking the left side looks more complicated. And what I notice, so that I'm going to use my new tool, is that in the denominator, I have a 1 plus cosine t. And 1 plus cosine t doesn't really do anything with the identities. So, of course, I can change cosine t to 1 over secant, but that's going to look worse because then I have a fraction and another fraction. And I might even think about how it kind of looks like a Pythagorean identity, but the Pythagorean identity that I know says sine squared x is equal to sine squared x is equal to 1 minus cosine squared. So there's a couple differences. The cosine would have to be squared, and there would have to be a minus there. And that's where the tool of multiplying by the conjugate comes in handy. What's the conjugate of 1 plus cosine? 1 minus cosine. So let's do it. We're going to multiply by the conjugate. And this is the conjugate of the denominator, specifically. So I'm going to have a sine squared t, and then in my denominator I'm going to have a 1 plus cosine t. Its conjugate is 1 minus cosine t. And if I multiply the denominator of my fraction by 1 minus cosine t, I have to multiply the numerator by 1 minus cosine t. And then that whole thing equals 1 minus cosine t. Now this part, some people might look at that and they'll be like, well, now I can cross off the 1 minus cosine t's. But then you're right back to where you started, right? So the goal here is to recognize what multiplying by a conjugate can do for you. If you FOIL out or distribute these two factors in the denominator, 1 times 1 is 1. On the outside, I'd get a negative cosine t. On the inside, I'd get a positive cosine t, which will cancel out. So I really just right now have 1. And then positive cosine times negative cosine is negative cosine squared. So I have sine squared t times 1 minus cosine t all over 1 minus cosine squared t equals 1 minus cosine t. And my reasoning right there would have been like either I multiplied, or some people might call it FOILing. If you would need to do that like off in the margin of your paper, you could. But that is essentially the beauty of a conjugate. If you multiply by the conjugate, it might turn out looking like your Pythagorean identity. 1 minus cosine squared is equal to sine squared. So now we can make the substitution in the denominator. So we have sine squared t over 1 minus cosine t all over sine squared t. I'll move this up here in just a second. So equals my 1 minus cosine t, and that's my Pythagorean identity. If I see in a denominator, if I see something like a 1 plus cotangent or a 1 minus tangent, I'm going to be thinking about that. Could I make that turn into one of my Pythagorean identities? Sometimes yes and sometimes no. It doesn't have to match. Okay, well obviously, simplifying you've got a proof, right? So your sine squareds cancel and you get 1 minus cosine t equals 1 minus cosine t. So notice I really just changed the left side. Like I chose that as my more difficult side. So I did all my simplifying over there. I didn't really change the right side. Okay, and that's okay. You can switch over to the right side if you want, but on this one I think it's easier to just do the left. Okay. Questions? Now I'm going to go back up to the top of my proof, or I call them proofs, but my verification. I'm going to ask you, I was trying to demonstrate the use of the new tool, right? Multiply by the conjugate. When you notice you've got a trig 1 plus or minus something in the denominator, maybe it'll turn into a Pythagorean identity. So you could try that. If we go back up to the beginning, was anybody thinking, as I forced you to multiply by the conjugate so that I could show that, was anybody thinking, why are we doing that? Why don't we just do this? So this goes back to like there's more than one right way to do the problem. In number 15 on the sideboard on the yellow paper, there's more than one right way to get from arm to leg. 2 people did it in 8. 1 person did it in 7. Is anyone better than the other? I don't know. I guess one less step. Okay, but there's multiple ways to get to the same answer. So Kylie is saying, could I have right here made a substitution of a Pythagorean identity? Sure. I could have said 1 minus cosine squared t over 1 plus cosine t equals 1 minus cosine t by Pythagorean identity. And if you think back to my tips from yesterday, that follows my tip that says get everything in the same trig ratio. Right? Now we have an example where everything is in cosines. Could that potentially be helpful? Yeah. After Kylie changes it to the Pythagorean identity, 1 minus cosine squared, then she has a difference of perfect squares. So this factors. It's 1 plus cosine t times 1 minus cosine t, all over 1 plus cosine t. And it's supposed to equal 1 minus cosine t. Is that going to work out? Yeah, it's going to cancel. So, maybe we're like, that was way easier, right? But I wanted to make sure that you have seen a multiply by the conjugate problem. But there's more than one way to do a problem, is the moral of that story. Okay, and what I'm going to be looking at on the quiz, and this, make sure everybody's listening for this, I don't care at the end that it says 1 minus cosine t equals 1 minus cosine t. I mean, I do. But the majority of your credit on the quiz on Friday is all the stuff in between. You can't skip stuff and then just like be like, oh, la, 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 I know it's 1 minus cosine t equals 1 minus cosine t. Magic, right? You got to show the steps in between. So truly, I care more about your work than your actual answer, although your answer should be right too. Okay, your homework assignment is, I think, on page 362. So again, you are required to do the bolded and underlined problems, so that's 4 of them. But those of you who are feeling pretty confident, I'd say do all 6. Okay. And if you didn't get last night's done, copy down what you might need from around the room. 1 or 2 steps, or get up and take a picture and get that completed. I'll be coming around tomorrow to take a look at your assignments. And there's less problems tonight because they're getting longer. So don't expect them all to solve out nicely in 2 to 3 steps. You might have to kind of work through, okay, and eventually you'll get there. So kind of persevere.